In this video, I'm going to introduce you to flowcharts. Now, flowcharts fall under the family of algorithms. Now, there are two types of algorithms that we'll be covering in this course. Those are flowcharts and pseudocode. Both of them have their weaknesses and strengths. In regards to flowcharts, you may have seen flowcharts before in such things as memes. However, flowcharts are designed to be a visual way of organizing the way we design our programming language. Now, there are 5 symbols that you need to be aware of inside software design development. The first is called Terminator, which is referred to as A here. The Terminator represents the beginning and end of a program. It's really important that you have terminators, because if we don't terminate programs properly, then they can cause issues such as using up memory for memory leaks, or at worst case, causing system crashes. The next symbol, which is a rectangle, represents the process. Now, the process is the instruction or the code instructions that we are writing. And we'll cover this in more detail further down in this video. The next, which is C, is the input or output, which is the parallelogram. So we have a different symbol if we're prompting the user to enter something, input, or you're going to externalize something for an output. Next one is D, which is a decision diamond. Some of our control structures, such as our binary, multi-way, and loops, we are allowed to have a decision, and that decision is represented through a diamond, and we'll cover that in future videos. And then finally, we have the subprogram, where if we have a large program, we can break it up into smaller modules, which helps us manage and program the particular program. We have an example here, which is a flowchart for determining someone's pay. If you look at the beginning, we have the Terminator, which is start. We then have an input-output, which displays how many hours did you work. We then have another input-output, which is basically to read or enter the hours in. We have one underneath that, which then displays the second question, is how much do you get paid an hour? And then we have a fourth symbol there, which is another input-output, which is then to enter the rate of pay. Now you can see there that the actual multiplication or the calculation of the pay is done inside a process. So this is what the computer program is going to do. Now, you can write this as a mathematical calculation, or you can write it as an English-like expression, as you see there. And then finally, we display the pay. Now, there are some rules around using flowcharts. The first is you should only include one set of instructions in one symbol. What that means is sometimes we have the temptation to put many instructions into one symbol. Now, I know modern programming languages let you do many instructions in one set of instructions, but you've got to remember, a flowchart is a design tool. So the purpose of a flowchart is to break down the instructions step by step, so you can walk through the logic of your computer code or your design and then work out if there's any better ways or issues with your code. So remember, only one instruction per symbol. The next one is ensuring that you include flow lines between each symbol. So when I say flow lines, is that each of the symbols must have an arrow indicating direction to the next symbol. This is really easy to overlook. It really becomes very important when we start working with the more advanced control structures, such as binary, multi-way, and loops, as you might have many different directions that you are flowing data from. We also have the way you format. Now, every decision, which we'll cover in more detail later on, inside the decision diamond, you should always have a clear condition. Now, this condition can either be a yes or no, a Boolean, relational, or logical, which will go in more detail inside the binary, multi-way, and loops. You can see an example here is we have a binary decision where is the amount less than $1,000? Yes, then the interest rate is 0.06. No, then the interest rate is 0.10. Now, it's really important that you both label the yes and no and make sure you have a condition inside the diamond. It doesn't really matter which way you go, yes or no, left or right, as long as you label it so the user understands what's going on. The next rule is that you'll find that one of the weaknesses of flowcharts is they get very large very quickly. The nature of them being visual, that's the reason why. So if you're going to use flowcharts for large programs, make sure you use connectors. So if you use a whole page up, what the connector does is it's almost like a please turn over symbol you might have used when you were in primary school or at school. So in this example here, we have A being a good connector, You can also use numbers if you would like, but either way will do. So that pretty much wraps up flowcharts. The strengths of flowcharts are pretty much anyone can understand them as long as they're well designed. The weaknesses are they're not really good for a very large software design. You'll find that they tend to blow out and are very hard to maintain.